Hello everyone and welcome to part 2 of the Item Toolkit FMECA module for performing failure modes, effects, and criticality analysis based on the MEAL standard 1629A, as well as functional safety analysis based on the IEC-61508 and ISO 26262. In part 1, we created a new project and a new FMECA system and populated this with blocks, components, and failure modes. We assigned failure effects to the next level and all the way to the system level, and finally we assigned severities to out-system failure modes or system end effects. Typically, a reliability engineer looking to perform a reliability analysis on their system would first import their bill of material into one of the prediction modules to obtain all the failure rates. Once this is done, they would like to take their prediction system across to a FMECA system to perform functional safety analysis. Here in part 2, I will show you how we would use an existing prediction module with blocks and components and convert this to a FMECA module to perform our functional safety analysis. Let's open an existing MEAL Handbook 217 system and convert this to a FMECA module. Here we have a prediction system with all the results calculated for the failure rates and MTBFs. Item Toolkit has lots of different options on the right mouse click button for every module, and you can always explore these options to see what is available and the functions you can perform. When we right mouse click on the MEAL Handbook 217 system, we see an option called Start Transfer To. When we select this option, we can see that the cursor symbol changed to a circular arrow indicating that we are in a transfer mode. To explore what module we can transfer our MEAL Handbook 217 system to, we can select the top node of the project window and right mouse click here and select End Transfer here. As we can see, a window pops up with all the different logical modules that we can transfer to. I can select to transfer to other prediction modules whereby the algorithm will convert my system with the closest component category match that can be found in the target prediction module. It is important to note that all prediction modules have different component categories and subcategories as they are based on different standards and different sources from military to telecom to naval. Any category or subcategory that cannot be matched will be transferred across as an external component. The user can then decide to change the component category by selecting one from the list within that particular standard. For this exercise, we are going to convert our MEAL Handbook 217 system to a FMECA system, so let's select FMECA. As we can see, there will be two options that become active, allowing us to transfer and link and include components. The transfer and link is where the software will create a link between the FMECA blocks and components and the prediction blocks and components. This is in case we decide to change any parameters in our prediction, which would lead to a new failure rate. Then our FMECA would be updated with the new results automatically. The second option is whether include all the lower level components or perform the FMECA at the higher level. For this exercise, we will check both flags and see what our FMECA system will look like. There's a further option to whether look up our components in our parts libraries during the transfer and assign existing failure modes automatically. I will show you this option in part 3 of this series on Item Toolkit FMECA module. Let's now click on OK and see what happens. As we can see, a new FMECA system has been created in our project with the same name as our prediction and same system settings. All block and components, part numbers, descriptions, as well as all their calculated failure rates have also been transferred to this new FMECA system. All we need to do now is to complete our FMECA analysis, is to define failure modes for our components and their effects to the next level and all the way to the system level, as described fully in part 1 of this tutorial. Let's now open an existing FMECA module and look further into the IEC-61508 standard and how we would complete our system with the diagnostic test data. In part 1, we learned how to add failure modes to our components. Each failure mode has a flag for detectability and a value that can be entered for the beta or probability. The same data is required within the IEC-61508. When we switch over to the Detectability tab, we can see two flags, one called Detectable and the other Immediately Evident. We can also see a value entry for the detectability, which by default is set to 1. Once again, this is similar to the beta or probability in MEAL Standard 1629A. So there are 3 questions that we need to answer here. 1. Is this failure detectable? 2. Is this failure immediately evident? 3. What is the detectability value, or what are the chances of this failure being detectable? Let's put in some random values for these modes and check out the results. I'm going to set one of these detectable flags to be off and the others on with different values for the detectability. As I do this, you will see the symbols for the failure modes on the hierarchy change to a solid red for the modes that are not detectable. This is an excellent feature which helps the user identify those undetectable failures immediately on the hierarchy. Let's now click on Perform Analysis button to see the results. Immediately, we can see the calculations for our failure modes Lambda Safe and Lambda Dangerous. These values are calculated all the way to the system level as part of the overall functional safety standard IEC-61508. The immediately evident flag is an additional flag introduced in this latest version purely for the transfer of these modes to a fault tree analysis and does not have any bearing on the calculation of the results in the IEC-61508 or ISO 26262. The next step for the IEC-61508 standard would be to define the diagnostic test data for each of our failure modes. The data entry procedure for this is very similar to assigning effects, whereby we select the required mode and once selected, we click on the Add button to add a new diagnostic test. Let's keep this exercise simple and add a generic name, description, function description, monitor reaction, and when it comes to the type of diagnostic test, then choices are as follows. If it is a continuous built-in test, then no interval data entry is required. For all other types, an interval of time is required, which will be taken into the overall calculations for the IEC-61508 standard. Once we have defined these diagnostic tests for one or more failure modes, the final step for the IEC-61508 standard would be to assign whether our system failure modes or system end effects are safe or dangerous failures for our system. This is similar to assigning the severities for our system end effects, which we covered in Part 1. We need to select the system node for our FMECA, and instead of selecting the Mode Info tab, we would select the Detectability tab. Here we can see our system end effect and radio buttons to assign these failures to be safe or dangerous. Once again, the settings at the system level for these end effects will be carried down all the way to the root causes. We can then run the analysis for our FMECA system to see the results for our diagnostic coverage by clicking on the Perform Analysis button. When we do this, the hierarchy will display all the calculations for the MEAL Standard 1629A, and when we switch over to the Diagnostic Coverage tab, we can see the results for our system end effect, showing the calculations for Lambda Safe, Lambda Dangerous, Lambda Safe Detected, Lambda Dangerous Detected, and so on. Also, in the latest version of Item Toolkit version 9.8.6, we have introduced a new tab to display the probability of failure on demand estimation. These calculations are done for the system using a set of default values, which can be changed by the user to suit their requirements. Finally, if we wanted to see the results for the Automotive Standard ISO 26262, we would simply select the top system node and the Block Info tab and switch over from IEC-61508 to ISO 26262. Now the results on the Diagnostic Coverage tab changes to the calculations required by the ISO 26262 standard. All of these results can be produced on tabular reports and saved as a PDF document, as we discovered in Part 1 of this tutorial. I hope this Part 2 of the Item Toolkit tutorial on the FMECA module has been helpful, and look forward to seeing you in Part 3, where we will explore the use of the phrase libraries, as well as the failure mode libraries, and how these libraries can help us in completing our task faster and more consistent.